Continuing section 5.3 with example 3, we're going to let P be a point on the unit circle that corresponds to T. And we're going to find the coordinates of P and the exact values of the trig functions of T whenever possible. So you need to be looking at your unit circle while you do this. All right, so we have 5 pi over 2. So what point is that? When we have radius of radian 5 pi over 2 radians, that's the point 0, 1, correct? So now we'll write out our 6 trig functions. All right. So the sine of t is y is 1. The cosine of t is x is 0. The tan of t is sine over cosine, 1 over 0 is undefined. The cosecant of t is the inverse of the sine of t. 1 over 1 is 1. Secant of t is 1 over 0 is undefined. And the cotan, this would have been 1 over 0, so this would be 0 over 1, and that's 0. Okay, that's all we're trying to do here. So negative pi over 2. Remember, that means you go in the clockwise direction from your positive x-axis. So what point is that if you go to negative pi over 2? That's the point x is 0, y is negative 1. So we'll write these out again. It's good practice. You have a plan on test day because you've done it a bunch of times. Okay, this is easy. Sine of t is y, cosine of t is x, tan of t, sine over cosine, that is undefined. Cosecant of t is 1 over negative 1, that's also negative 1. 1 over 0 for the secant, of course, is undefined. And, whoops, not showing you, am I? And the cotangent, 1 is similar to what we just did last time, so it ends up being 0 over 1 or 0. All right, where are we at 3 pi over 4? We're at the point where x is negative square root of 2 over 2, and y is square root of 2 over 2. Second quadrant. Sine of t, cosine of t, tan t, cosecant t, secant t, and cotan t. Okay, so here we go again. Sine, that's messy. The sine of t is y. Square root of 2 over 2. Cosine is x, negative square root of 2 over 2. And when we put sine over the cosine, what do we get? Negative 1. And we can't even see this. Goodness gracious. Let me slow down. So we're at the point negative square root of 2 over 2, square root of 2 over 2. There's our y, there's our x, and there's y over x. Okay, cosecant of t. It's the reciprocal of the secant, right? So we would have 2 over the square root of 2. But we'll often see this with the denominator rationalized. So we get 2 square root of 2 over 2, which is the square root of 2, right? Secant. Same thing happens, doesn't it? Because you have negative 2 over the square root of 2, so that ends up being negative square root of 2 for the same reason. And cotan, of course, the reciprocal of negative 1 is negative 1. All right, where on your unit circle are you when you're at negative 7 pi over 4 radians? So you're going clockwise, 7 pi over 4 radians. What quadrant do you end up in? Well, pi over 2, negative pi over 2, we found ourselves to be in the which quadrant were we in? Oh yeah, for negative we went down, right? We knew where that was. So then we went, if we ended up going 7 pi over 4, well, look where it is on your unit circle, but then think about going that distance all the way around. So it's in your, the 7 pi over 4 positive is in the 4th quadrant, right? But if you start at 0 radians and go clockwise and go 7 pi over 4, you end up in the 1st quadrant, right where pi over 4 is. Okay? So that's where you would end up, and so your point is square root of 2 over 2, square root of 2 over 2. You have traveled 7 pi over 4 radians in the clockwise direction. That's what that means. So that we have to make that adjustment. So sine t, cosine t, tan t, and cosecant t, secant t, t. All right, y is our sine, x is our cosine, y over x is our tan. The reciprocal of the sine, we saw that that's going to be the square root of 2 after you rationalize the denominator. So will be the secant, and of course the cotan is 1. Let's see if we can get example 4. So to do example 4, we need to understand this formula for negatives. And what it basically shows, if you just look at it for a minute, if you take the sine of negative t, that's the same thing as the opposite of the sine of t. And of course, that's true for its reciprocal. But when we see the cosine, it doesn't do that. The sine of the negative is the same thing as just the cosine of the negative is the same thing as the cosine of the positive and its reciprocal. And then the tan, though, acts like the sine. So this is the only one right here, or these two, cosine and secant. But if you remember cosine, you know secant's just going to follow along, right? Whatever cosine's doing, secant's going to do. So that's the one where it ends up being the positive. Everything else, you just pull the negative out. So in other words, sine of negative 3 pi over 2, we just say it's the opposite of the sine of 3 pi over 2. And we can get that, right? Because we have that on our unit circle. So what does it say on your unit circle? It says that that is -1, right? But don't forget, we have a negative out front, so it's 1. Okay, now the cosine of -225, remember cosine's the one that's weird. It just says, it's the same thing as the cosine of 225. Right? On your unit circle, the cosine of 225 is the negative square root of 2 over 2. And tan does the same thing as sine. We just pull the negative out. Now we haven't done anything with tangent yet. We're going to have to figure out what the tangent is looking at our unit circle. So this is going to be, I'm going to write this out, it's going to be the same as the negative of, and I'll keep that separate, sine pi over 4 over cosine pi over 4, right? It's sine over cosine. So what is the sine of pi over 4? Well, it's the square root of 2 over 2, isn't it? And, oh, don't forget our negative on the outside here. And our cosine is also negative square root of 2 over 2. So we just get -1 for that tan. This would be 1 in the negative. We have one more example. Let's try and fit that one in on this video. I don't think it'll take that long. Okay. Using the unit circle, find the exact values of x in the intervals 0 to 4 pi that satisfy the equation. Well, what does that mean? That means 2 revolutions. Go around twice and tell me how many times you find the sign is 1. For what values of x do you find the sign is 1 going around twice? Well, where do we see that happen? We see that happen when x is pi over 2, and then it doesn't happen again until 5 pi over 2. Add 2 pi to go around again, and you're right back in the same spot, but you're at 5 pi over 2, right? So what did I do? A way to find that, pi over 2 plus 2 pi. Which, of course, I need a common denominator. Four pi over 2, and that's where I get my 5 pi over 2. I won't see a sign being 1 again till I've gone around one full other revolution, or 2 pi. But we know the sign of x is equal to negative square root of 2 over 2. In one revolution, that happens twice, doesn't it? Where do you see that happen in one revolution? Well, it's whenever you're in the second or the, it's whenever you're in the third or the fourth quadrant, right? So, because it's y, right? So when y is negative, third and fourth quadrant. So it happens at 5 pi over 4, and again at 7 pi over 4. Add 2 pi to that, add 2 pi to that, and you've got your other 2. You've got to go around again and again to get those 2. So I won't show you how to add 2 pi to those again. You can do that. So adding 2 pi to 5 pi over 4, I get 13 pi over 4, and 2 pi to 7 pi over 4, I get 15 pi over 4. Okay, these are all the places in 2 revolutions where the sign is negative square root of 2 over 2. Where will we see the cosine be negative 1? Well, that's kind of like that first one. We're only going to see it once a revolution, right? So we see it, looking on your unit circle, when x is pi, right? There's your negative 1. And then go around another time, you've gone to 3 pi. Finally, where are we going to see cosine negative 1/2? Looking at your unit circle, where do you see that happen? Of course, the cosine is the x-coordinate, and the x-coordinates are negative in the second and third quadrant, right? So we see this happen when x is equal to 2 pi over 3, and then it'll happen again as we continue our revolution at 4 pi over 3, because it happens in 2 quadrants. And then add 2 pi to get the other 2. So we get 8 pi over 3 and 10 pi over 3. Okay? So that should set you up for your homework for section 5.3. Practice the unit circle. It's critical that you're able to develop that unit circle.